Hello, everyone. In this lecture, we're going to look at this metal cutting tool wheel experiment. And to solve this exercise, let's first have a look at the exercise together. You see here is a Haas machine, and we have different kind of cutting tools. An experiment was performed to compare the abrasive wheel of two different coating materials on the cutting tools. So coating material A, 12 pieces were tested on the Haas CNC machine. And then the depth of wheel, that means you have 12 machine tools. They were coated with material A. And then you're going to test it on the Haas CNC machine. And then the depths of wheel were measured in each case. The sample of material A gave an average wheel of 85 units within a sample standard deviation of 4 units. And for coating material B, 10 pieces were similarly tested. In each case, the depth of wheel was observed. The sample of material B gave an average of 81 units with a sample standard deviation of 5. Can we conclude at the 0.05 levels of significance, that's 5% significant level, that the abrasive wheel of material A exceeds that of material B by more than 2 units? Okay, assume the population to be approximately normal with equal variance. You see, let's assume to be approximately normal with equal variance. Equal variance. So here, why do we need to compare? So here we have two populations. Okay, population A, population B, different kind of materials. You coat it on the cutting tool. And then you cut some of them and then you compare which one is better, which material is better. This kind of question is commonly asked during manufacturing because you can compare materials, you can compare machines, and you can compare different kind of operations to see which one give you better results. So this is called compare or test on the difference of two population means. Okay, and the variance unknown. So here we don't know the variance. What we were given is the sample standard deviation, sample variance. And we don't know the variance of two populations are equal or not. So we have the formulas for this kind of problems, and I have posted in the Canvas website. Now, if you go to the general procedures for hypothesis testing, obviously, so far we have already tested on the single mean. And population variance known, you use population variance. Population variance unknown, you use the sample standard deviation. Now, for the comparison of two population means, you have 1, 2, 3, and 4 cases. Okay, so we're going to talk about this one later. This is paired observation. However, for the first and for this one, and this one, the first one is we know the population variance of both population variances. That means sigma 1 and sigma 2 are known. Then you know the sample size, and you can follow this, and then you can do the hypothesis testing. And the second case is population variance unknown. Both of them are unknown, but you assume equal variance. And this one is also unknown, but you assume an unequal variance. Okay. So whether if you got two population, you can also test on the population variance. That means you want to see whether the variance equal to each other or not. And that is a test that we're going to talk about later. But here, sometimes you may given that for the problems, you may be given that it's equal or not. And also, but both of them are unknown. But for our case, it's unknown, and we assume equal variance. So we're going to use this case. That means we're going to calculate the test statistic in this way. And then we approximate the sample standard deviation because we assume equal variance. Then we can combine the first sample with the second sample to approximate the sample standard deviation. This is approximation. That means the first, you see this is a weighted average. S1 square is the sample one variance, and this is the sample variance of the second group of sample. And then based on the sample size, you're trying to do an average, and then you put it over here. So then you 1 over n1, 1 over n2. And the degree of freedom, because you have two samples, and then it's n1 minus 1 plus n2 minus 1. So that's n1 plus n2 minus 2. And then once you get the t, once you get the test statistic, you want to see what kind of test you're going to do. So the null hypothesis is always equals to, they have a particular, equals to a particular difference. This is a left-sided, you see left-sided is still very similar, right-sided, and then two-sided. Okay. So this is a formula we're going to use to test this hypothesis, the difference of two population means. Now let's do it together. Again, step one, formulate hypothesis. H naught. Then now it's mu1 minus mu2 equals to 2, exceeded by 2 units, right? And then mu1 minus mu2 by more than, then this is right-sided. Now step two, compute the test statistic. So this is t equals to x1. Let's see what kind of notation did we use. We just use the t here, right? So let's just use t. x1 minus x2 bar, and then minus d0 divided by sp times 1 over n1 plus 1 over n2. And the degree of freedom is n1 plus n2 minus 2. So what is n1? n1 is 12 pieces 10, so 12 plus 10 minus 2. So this is 20. Now what is x1 bar? X1 bar is 85, and n1 is 12, and S1 equals to 4. X2 bar equals to 81, N2 equals to 10, S2 equals to 5. So if we, we have to first approximate our SP. SP equals to N1 minus 1 S1 square plus N2 minus 1 S2 square divided by N1 plus N2 minus 2. Is it right? Yes. So this will equals to, let's put these numbers in. This will equals to 4. This is a S square, right? So this is a S square, so we have to take the square root. SP squared. This is 4.478. And then now we will be able to get a t equals to 85 minus 81 minus 2 divided by 4.478 and times 1 over 12 plus 1 over 10. This equals to 1.04. Okay. Now, let's get the p-value. Now, step 4, step 3. If we want to get the p-value, so first the critical value approach. Critical value approach, we need to find out this is less than or greater than this T alpha. T alpha will be T.05 will equals to 1.725. So we are going to, and also the p-value equals to probability T greater than T. So this will equals to probability T greater than 1.04. This will approximately equals to 0.16. Okay. So now we are going to reject H naught if T greater than T alpha. Obviously, our 1.04 is less than 1.725. Or if p-value less than 0.05, obviously this is greater than, however, 0.16 is greater than 0.05. So we do not reject H naught. That means you don't have enough evidence that the difference is more than 2 units. So we are unable to conclude that the abrasive wheel of material A exceeded that of material B by more than 2 units. We are unable to conclude that. So this is the end of this exercise. Compare the difference between two population means. However, we assume equal variance, equal population variance, and they are unknown.